All right, hi. Some haunting Soviet children's music for you. Anyway, yeah, we have a couple kids. We jam out to that pretty often, that kind of thing. Anyway, hi. So what do we got today? I'll let you guys drive. Let's see. So today, let me share my screen. So quiet in here. All right. Yeah. We're on lecture 6. So what do you want to know about? Anybody? Bring on some questions. I'm ready. Sandra.
Hi, Professor.
Hi.
My question is on the generic list when you did the, like we don't have to declare the type of list we're doing. So I'm wondering, in that case, what should we put for the Sentinel first item?
Good question. So let's see. So if we go into, yeah, when we create such a list, is it not in this here? Hold on a sec. When does this happen in lecture? I do talk about it. One sec. Loitering. Looking for a phrase. Loitering. Right. Okay. So I haven't said it yet, but I will talk about it a little bit in the next lecture. So the boring answer is null.
Okay. Cool.
Cool. Yeah.
And another quick question: when we were trying to like create a new list, there are a couple different methods you talked about, and in the demo it says like int bracket z equals null and then int bracket xy. I'm wondering, are those kind of equivalent? Like, is saying int bracket z equals no kind of like useless?
Yeah, it is useless, right? Where does that happen actually in the lecture? It's in the array review.
It's the slide that says
right
array
here.
basics.
Yeah. So this it's not useful for anything. The only thing it lets you do is have a null int array, but there's no reason you would ever do that, right? Yeah.
Okay, cool. So essentially, the first 2 lines kind of do the same thing, right?
Not quite, because this one actually initializes it to null. These create variables that don't exist initially.
Okay.
Yeah. In other words, if you
Okay.
tried to do like,
Cool. Thank you.
yeah, if you tried to do system.out.println z here, it would be fine. It would just print out the word null. If you did this, it would not compile because not declared. Make sense?
Okay. Yeah. Thank you.
Yeah. Cool. Steve.
Hello, Professor.
Hi.
Great. So I have two questions. So my first question is, it's like when doing the size of the list iteratively for the I think I can't really remember which one you did iteratively, but I think it
Yeah.
was the S list, maybe. Yeah.
This is in a one lecture back, lecture 5, I think, right?
Yes.
Okay.
Yes.
Yep.
This
Let me
one
open up
lecture
the
back.
code in IntelliJ.
Cool.
And let me grab this. All right, cool. So this is
Awesome.
S list. Great. Okay. Yeah. So when we did it iteratively, the size, here we go. Yeah. Okay. Right.
So before you actually kind of like catch the size.
Yeah, right. Sorry,
Yeah.
let me go back. I don't have actually in code, but I'll show it in one sec. Okay. By the way, sorry everybody, I'm squeezing lunch in the middle of teaching because I didn't have time. I've had back-to-back meetings. Okay, here's the recursive version. Okay, yeah.
Yeah. See.
And so, did I do an iterative version at some point?
I think there was one you did an iterative version. I don't know if it's an S list or it's the end
maybe
list or something.
Here's add last is iterative. Yeah.
But it was the size method actually.
Oh, it was the size method. Okay. Yeah.
Yeah.
Let's see. Would have done that? I could have done it.
Maybe you
let's just
changed
do it.
it,
Let's do it.
but
Let's do
it
it
was
anyway.
like, yeah, basically the main question I had was like, in that method, you kind of instantiated another object. You called it P.
Yep.
Then you kind of like, I was going to say modify P.
Right. Yeah.
Basically.
Yeah. Very common pattern with iterative code.
Yeah.
Yeah.
And I was confused because like I thought when you create like an object and you assign it to another object, if you change that object, for example, like basically since it has like the address of the other object, I thought the other object is going to change.
Got
as
it.
well.
All right. So this will become clear with the visualizer. Ready? So while p.next, or sorry, while p is not equal to null, size equals size plus 1, p equals p dot next, return size. Okay, cool. So let's run iterative size on a list. We're going to be ultra careful about what we're doing. So let me say first that the answer is simple, but only if you really get the basic rules down. So there's nothing new happening here. Just like we want to be extremely cautious in how we think about what's going on. Why is it running this? Nope, wrong one. What did I do? Hold on a sec. I need to run SLS no sentinel. Okay. Oh, sorry, there's a compilation issue. One sec. If I list to int list. What's this file? Oh, I was messing with something in the previous lecture. That's why. Okay, sorry.
Maybe this is actually lecture 3. I don't know.
No, you're right. It's or maybe it was, but at any rate, we can do it in slist no sentinel. Sorry, one sec. Okay. Okay. All right. Java wanted me to make sure that that file was working before to run this one. Okay, great. All right. So now, there we go. Size. We look at the debugger. Oh, what is going on? Sorry, one sec. One more time. Okay, good. All right, step over. Visualizer. Okay. So after I add first, add 0, add 20, I have a list. Hold on a minute. All right. I need to do something real quick, which is to fix my code so that it is not broken from last time we were messing with it in lecture. One moment. Sorry, everybody. Okay. It'll all become clear. We need to go back to lecture code. Now we're back to a sane state, presumably. Okay. Oh. Bleh. Okay. I'm just changing things slightly to do what I want. Okay. So. Problem I have just now is that I was using a piece of code that we wrote in the middle of the last Q&A that I guess has a bug in it. Okay. Are you ready? Sorry, Steve. All right, here we go. So when we run this code, we're going to step into this iterative size method. All right, are you ready? Hopefully. I don't know if I lost you in that time. Steve, you still there? Well, maybe just your sound's off. All right, I'm going to provide the explanation whether or not you're still there. So when we call p equals sentinel.next, after all that time, we're creating a new variable p, which is pointing at this node. Does that make sense? Are you here, Steve? Okay. I'm going to assume you can hear me, but I just can't respond.
It's in the chat.
Oh, good. Oh, sweet. Okay. All right. So here we go. We got p. Thank you for noting that's in the chat. Thank you, Steve. Okay, so p is pointing at this variable here, right? And when we do step, when we say p equals p dot next, it's only changing this variable, which is a local variable, to the to this function. So we're just changing this memory box. We're saying this variable is going to get these bits. Which bits? Well, we mean the bits in this p.next box, like the address of this. So all that happens is that p is now pointing at this object. So we're not actually messing with L. Like L points at a sentinel, which points at this, which points at this, da, 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 da. But we're not messing with L or any of these pointers. We're just changing this local variable. So as we do this, we're not actually affecting the list in any way. P is just a pointer that hops along the list, and then it's retired because we don't care about it anymore. And then we're done. All right. Hopefully that made sense. All right, great. Sounds good. All right, sorry everybody else that I had that code kind of in a bad state. You had to watch me fumble around for a bit. All right. Cereal. Yes, indeed it is cereal. Had to make lunch in 1 minute. That's the easiest thing. Claire.
Hi, could we go back to like the previous question, like the slides?
Yeah. So going back to the slides here, these, or where were we?
It was like the arrays, I think.
Right. Okay. Sounds good. Oh, sorry, I'm one lecture ahead. We need this arrays right here. Yeah. Here.
We can't see. It still
still
shows
on the other one. Oh, I thought I was sharing the whole screen. I'm sorry. Okay. There you go.
Yeah. So, when you're like, I'm still kind of confused about like the whole like memory and like the bits. So like on the like when we like draw out the diagram, like if you go to the next slide. So like on the blue side, it holds the memory address. So does that mean like it's like the location of where the array is located at?
That's the way you think about it conceptually. Yeah. So like Z is 64 bits that point at the that is like a written address. So you can think of Z. What's in Z? Like if we could zoom in, it would be like let's see, no line. So these bits here are basically 64 bits that say something like 35 Center Street, Berkeley, California. But address is in a computer, and you'll learn what that is in 61C if you take it. So that's how I would think about it. Z is the address of that. Yeah.
So like that is that like because like technically an array, like the first array, like array for like the X, that's like 160 bits, right? So how does that?
This whole thing right here. Yeah.
So like how does that fit into the 64 bits?
Right. It doesn't. Yeah. So this is 64 bits that says, oh, this is like 72, sorry. Center Street, Berkeley, California. And So this is like only a relatively like short string, but you could have an arbitrarily large object at that address in the sense that like you could build skyscrapers or whatever, right? So that's sort of a tortured analogy, but it's not that this object needs to fit in this in these 64 bits, right? Because there's not enough. You can't fit 100. If I take this, I'm going to make another slide real quick. So if I get rid of all this stuff, I grab this. So as you note, this thing right here is, no, not the whole thing, sorry. So this thing is, how many bits did you say the X is?
160.
Right, 160 bits. It will not fit in that 64-bit spot. So this thing, if you want to think about it, like, you know, the analogy with addresses in Berkeley kind of breaks down because in the real world, like buildings and addresses are different things, right? But inside a computer, it's all just bits. So it's like, that's where the analogy breaks down. But you're right, that 64 bits here, you can't fit it there. But what you can fit is the address of it in memory. Make sense?
Okay.
Yeah, but it really 61C is where it will really truly make sense. Yeah, right now it's a little bit mysterious.
And also, just to clarify, like in order for an array to like have like null values, like we have to specifically say that, right? Otherwise, it'll be like 0 instead.
It depends on the type, actually. So if we have integers and we don't specify, we get zeros by default. If we have strings, though, you get nulls by default.
Okay, no, okay.
Yeah. So it's one of those like kind of weird rules. So if you don't declare, so if you don't assign a variable, it's not null, it's not 0, it's just nothing. By contrast, when you create an array, every space has to have something.
Okay.
Yeah. All right. Yeah. Not a super important rule, but a rule nonetheless. Anybody? So I know that I have 5 questions right now. Does anybody have a follow-up on this specifically? Feel free to jump in if you do. Okay, Claire.
I'm sorry. Do each of the elements have a have an address attached to their memory as well?
Let's see. Yes, technically they do. So it's not something that's exposed in Java, but if the address, and I guess I'll give an address that's more typical. If the address is, let's say 10,000, because the addresses are just numbers, then it is true that this item will be in memory location 100,000 and let's say 1. And this will be in memory location 100,002. So yeah, they're consecutive. And in 61C, you'll talk about that stuff.
So if you append a list, does it put it in a new block of memory? Or does it just use pointers?
If you append a list, what do you mean by a list?
Or like if you append an array, sorry.
Yeah, so if you use a function that appends to arrays, we can't append arrays natively in Java, but I'm sure that there's something. How do you append an array in Java? Is there a function that does this built in? Because typically what you do is you build a new array and then you append them yourself. Arrayutils.addall.
Okay, so it's just going to copy the original list.
Yeah.
Okay.
Now, if you do a list, like if you've ever used Java in the past, like in a previous class, if you're using an array list, then and you append to or you combine 2 lists, then underneath the hood, it's combining 2 arrays into a new array, which makes a new block of memory. If it's a linked list, then it does something like what we did. Yeah.
Thank you.
You got it. All right.
Professor, just a quick follow-up with this. So does it mean like anytime we create a new object, whether it's like a string object or any object, it just sets aside 64 bits for the reference reference type, and then when we instantiate it, then it sets in like the space we want for the rest of like maybe like the instance variables and stuff like that.
Exactly right. Yeah. So once you use the word new, right? We say new cat, new tile, new board, whatever. That's when the memory gets allocated for the instance variables. Otherwise, you just have the 64 bits for the variable.
Awesome. Thanks.
Yeah. Cool. All right. Katan.
Hi, Professor.
Hi.
I had a couple of questions. So my first questions are related to the discussion worksheet that we had yesterday. I noticed that in the print statement, there was a string dot value of call,
Yeah.
and I wasn't exactly sure like why you would do that, because when I just like messed around with it a little bit and tested some other stuff, I saw that if you just append the variable itself,
Yeah.
it still works. So like, what's the reason you would do that?
Yeah, sorry, this is in what context? This is in the
worksheet from yesterday's studies group session.
Right, okay, cool. So let me look at it real quick. This is here. This thing?
No, not that one.
No, let's see.
I can send the link in the chat.
Go for it. Is it this one? Yeah, send the link.
Yeah, I sent the link in the chat.
Ah, right, okay, yeah. Okay, so which one is this?
All the way at the bottom.
Mm-hmm. Okay, we do.
There's a print statement over there with string dot value of
a dot age. Oh, that's interesting. A dot age. So you're right that it will automatically do that, and that this is redundant. Interesting. I don't know why the worksheet designers decided to do that. It's not necessary. Yeah. Okay. Yeah, I'd be curious to know why. Yeah, I'll ask. But you're right. You don't have to do it. It's a more verbose way of doing the same thing. It turns out that that's actually what it does under the hood. Like this call gets made if you don't put a.age.
Oh, okay.
Yeah, yeah. Yeah. So stylistic choice by the worksheet creator.
And my second quick question was about when you're passing in parameters to methods, whatever you do with those parameters only happens inside the local scope of the method, right? It doesn't update the variables like in the main method, for example.
That's right, with the one caveat that if you have a situation where you're passing a walrus object, for example, from lecture 4, like here, when I create a walrus, and then sorry, wrong one. Okay. So when I take a walrus and I pass it into a function like so, yeah, right. So I create a walrus, and then I pass it in to do stuff. Here, they changed the walrus. What do you think will happen? Do you know the answer?
Yeah, the weight of the walrus does get updated.
Yep. Right.
Right, yeah. But I was wondering if you did something like W equals some new walrus,
right.
It wouldn't change the original walrus in the main, right?
Yep. That's exactly right. There's no external effect because this variable cannot be affected by do stuff. The language Java does not support that. Other languages do, but not Java. And by the way, that is called pass by value, just so you know.
All right, thank you.
You got it, cool. I would like to note that someone spotted a bug in my size method. This is kind of related to what you were just saying in a way. My iterative size method was using the instance variable size and incrementing it. So I should have declared a variable here, int size equals 0. This is a little artificial. You definitely don't want local variables that are the same as your instance variables, but for this little demo and lecture, so I did. Right? I don't know. I guess I'll call it S. How about that? All right. The bug is gone. Anyway, just in case anybody's watching this later, just so you know, there was a bug. All right. Let's see. I'm gonna look at the chat real quick in case there's anything. Okay. All right, Daniel.
Yeah, I had a couple questions. The first one is about when you have an array size of 0, I noticed that in the Java visualizer, it actually returns an empty array rather than like a null array. Could you explain the caveat?
Yeah, so they are different. And the difference is that if you were to ask for dot length, maybe as an example of something where it's actually different. If you ask for a null objects dot length, then it will say null pointer exception. Let me find the code. I know it's lecture 6. Yeah. All right, here we go. Right. So whenever we do x dot length, if this had been a, I could do z dot length here because z was set to new int 0. But if I had another array called in, let's say, and I did in like this and said null, this would cause a null pointer exception when this line runs. Does that make sense?
Right.
So that's one distinction. It's not practically useful to have length 0 arrays, but there may be like base cases of some recursive code where you might want to do it. But yeah.
All right.
Yeah.
And then for my next question, I was concerned about it's in regards to array copy. Is the nature of how array copy works, if you try to copy part of an array that's out of bounds,
right? What will happen?
Have a array that you're copying from have a correct bound, but it'll end up stepping over or under in the other
destination
too. Yeah.
Yeah, my guess, I haven't played with it in a while, but I'm almost certain that Java will, at runtime, have an array index out of bounds exception. That's my guess.
All right.
Only one way to know. Java is a relatively safe language, and that these type of memory errors are caught at runtime. Other lower level languages let you run right over the buffer sometimes.
And then my last question was about kind of checking for types in 2D arrays or multi-dimensional arrays. It seems that you can have another array of the same type in like say like an int array and an int array, but is this more, I guess, does this work with casting? Like as long as the array that you're putting inside int array is like, I guess, a parent class, I suppose.
Oh, so you're saying like, let's say we had, I'm gonna make them up. Let's do dog, or how about this? Dog. Colors are messed up. Okay, so let's say I do that. You're asking, can I do something like that?
Inside the index of the array. So like in this instance, we have matrix is equal to new dog.
Yeah.
Wondering that if like we could have like an animal inside an index of the dog array as long as it's casted.
Animal inside the index of the dog array. Well, the indices must be numbers though. Like the thing I'm a little confused about is you're saying like having some type here that's not.
Or I meant like, or like inside the actual like box of memory, not the index, I mean.
Right. Okay. Oh, here. So if these are things of type
like animal, for example.
So I will at first, let me preface this. If you have no idea what we're talking about, that's normal. We haven't done this yet. This is lecture 8. Anyway, I'll address your question, but I want to make sure people aren't panicking about this, the casting inheritance stuff. So if we have a dog array, something like this, you want to know what can be stored in these memory boxes? Could we?
Right.
Why is it a 2D array problem and not a 1D array problem? I guess I should first ask.
I guess it's not necessarily a 2D array problem, but
okay, let's do the 1D version just to keep things simpler, real quick.
Right. There's a follow-up to this.
Okay, sounds good. So again, we are currently out of scope. So anybody who's like, huh, what's happening? That's normal. If I have a dog array that is like x equals new dog 5 or something, and then I want to do like x0 equals like I'm just gonna say new animal. I'll say that's the thing I can do. So this specific example I've just made up does not work because an animal is not necessarily a dog. The other way works fine. Like if I have an array of animals, and I do x0 equals new dog, that's totally fine. So this works, does not work. All right, does that make sense?
Yeah.
And casting can't help you in either case. Like it doesn't do anything for you.
Okay.
Yeah. Does the 2D
then,
question make sense then? Do you still have a 2D question?
Yeah, the 2D question would be like, it seems that like, instead of having like an int in like the first index, if you have a 2-dimensional array, it supports like a dog array, for example, or like in the.
I think I know what you're getting at. Okay.
Yeah. Okay.
So you're saying like if I have new dog like 5 or something.
Yeah.
Is there a point whenever I might push something in here or in here that would not be an integer?
What do you mean by that? Wait.
Well, it sounds like you're saying since it's an array of dogs, could I ever pass in that there's something special going on with the typing, basically. All right, I'm trying to interpolate what your question might be. I guess not. All right, hold on a second.
I don't think that's where I was
going.
Oh,
you could do something like this.
Okay.
Say like that. That would be fine.
Okay. I was more so like thinking about like the particular, like when you input a number for the first index.
Yeah.
First index returns another dog array, right? So
exactly.
I was thinking about like more specifically like if you had like I guess related to like the second example, it would be like a 2-dimensional animal array equal to new animal, like say like 5, right?
Yeah.
And then we had x0 and the second index being blank. Is equal to like a new, like that.
Oh,
like,
right.
Yeah, right.
Oh, I see. Can we do something like this? So that it would actually just be this right here, by the way. Could you do this? I believe so. The thing you're asking about is whether, so good?
Like 2-dimensional for the type.
Oh, this side.
Or no, the left side. So left-hand side is 2-dimensional for both.
Okay, hold on a sec. The left-hand side is 2-dimensional.
Or for the animal, not the.
Oh, yes. Thank you. Yeah. Okay.
Yeah. Okay, that, yeah.
This right here, right. So what you're asking basically is, right, our array types, so the phrase people would use in programming language theory, it would be about type covariance. That's the phrase. I'm nearly certain it is. The more natural place where this comes up is not in the context of 2D arrays, but actually in the context of functions. So if I have, for example, a public void eat animal X or whatever, can you pass in new dog 5, right? Like this is basically the same phenomenon as the one you're trying to digest, which is like given an animal, if someone wants an animal array, can I give them a dog array? Is that right?
Yeah.
So these two, this is the 2D array version of the same thing as this, I think, and it has to do with whether array types are covariant, is the phrase people might use, and I'm 99% sure the answer is yes. I will note that somewhat related, maybe I'm abusing the term covariant. Sorry, I'm not a programming languages guy. I think that's right. So I apologize if I'm not. There's another thing, which I'll just throw out there real quick, which is if somebody asks for a list of animals, just for fun. Sorry, everybody. We're going off into the space universe. Can you do eat new list of dog? This will not work. And I would say I'm 99% sure. Right, so just be aware that's a thing. But yeah, the best way is to experiment. Anyway, the PL term for all this is covariance. I'm going to take another question since we've gone off into the abyss, but I hope that was interesting.
Yeah.
All right, cool. All right, Pratyush.
Sorry, afternoon, Professor. It's about that S-list to lockness.
Yeah.
So when we have public class S-list lockness, does that inner class to private class stuff node?
Let's see. So if we go to the lockness version, I was gonna go to the video since I don't think I have any code. Actually, okay. This is generics here. Okay. Right
there.
All right, lockness. Right. Okay. So you're asking is what?
Also, else.
One more time.
I get the lockness thing that you have this type, but how are you able to put the? Oh, sorry. What? Oh, how are you able to do the public lockness item inside the private class stuff node? Because even though I get that you didn't make the type yet, how are you able to put the type in an inner class?
Right. So this inner class here, like, why does it accept locknesses?
Yeah, in the inner class, like the public lockness item and public class stuff node.
Yeah. Sorry. Point. Where at? Sorry.
Is that
up top?
Up top. Right. Okay. Why can we do public lockness item here?
Yes. Yes.
So tell me why you think it doesn't make sense.
Because it's an inner class. So even though you put the lockness in the outer class, I can't wrap my hand around how you're able to put in the inner class.
Right. So what I would do is this lockness at the top, you should think of it as a placeholder, right? Well, like a template or something. It's like it's not anything that's been chosen, declared, anything. It's like a special syntax that says someone someday later is going to put integer or double or string or who knows what here. And therefore, anytime I use it in the code, I'm using that placeholder, right? So you can imagine that when someone actually creates an S list of strings, that it's like someone takes this file and Control Fs and replaces the word lockness with string. Does it make sense?
Yes. Since there's a lot of questions, I got it.
Yeah. Makes sense? Yeah. It's a strange thing. And like yeah, generics are, even though they can be kind of intuitive, they are a bit of a pain to really wrap your brain around. And if you knew how Java's generics work under the hood, you'd be even more confused. Cool.
Thank you.
You got it. All right. Austin.
Hey, Professor. You already answered my question, the first one about the iterative size.
Right.
My second is more conceptual.
Sure.
So it seems like in the real world, they use like Vim and text editors. So I'm wondering, like, should we be concerned about relying too much on like the debugger and the conditional breaks and that kind of thing?
No, I don't think so. And also, I would say in the real world, people use IntelliJ more than they use
really?
Vim.
Cool.
Yeah. I mean, it depends. If you're a Java developer, yes. Yeah, I like IntelliJ because it's a real world tool. Yeah. That said, there's development environments that aren't as mature. And so people prefer Vim or Emacs or whatever. And, people find their own way. I think obviously the visualizer is a very didactic tool, but I don't think you'll get over reliant on it because the habits that you build using the visualizer and so forth, they serve you even if you're stuck in an environment where all you can do is print statement debugging. Yeah. Yeah.
Thank you.
Cool. All right. Xiangwei.
Hey, Professor. I have a question about lecture 5 about this size. Size method. Yeah.
Right.
I wonder why cannot we just write that method as at last, which means we first initiate, like we can write.
Yeah. Sorry. Can you give me the context at which we're working on this? So this is before. This is when we're here, roughly.
Yeah.
Like before we cache anything.
Size. Yeah.
Right.
Size. Yeah. I wonder. Why we cannot make it into one method? For example, like we can say int node p equals first, and then write those iterative things.
Okay, int node p equals first. Yeah, you can. Oh, you're saying do an iterative version? Or actually, let me try and do it real quick. Okay, so you're saying public int size. Another one, sorry. I'll call it size x named after you. And you're saying I could do int node p equals, this is with the Sentinel, but whatever. So we could start it here, and then you're saying do what?
And then the same thing, like p, p.next. Yeah. Now equal to now
Right.
p equals p dot next.
Right. Oh yeah, you certainly can. No problem. Yeah. This is the iterative approach. This is the recursive approach. Both are equally valid. I just wanted to show this because this kind of code will be really important when we get to binary search trees.
Oh, so actually, okay. So also this thing, if you like one method is also okay in this. It's okay for size.
Yeah, sure. Yeah. This is the iterative approach. Actually, I already had it, so I'll just delete that. So this is, and actually on project 1, you'll do both. So this is the iterative approach, and then the slide version is the recursive approach.
Oh, yes. Yeah. Okay, thank you.
You got it. Yeah. And so again, like the recursive approach is like, it's a different way of thinking. It's more beautiful in certain circumstances, but there's one place in this class where it's much better to write recursive code, which is when we get to search trees. Well, I guess also some data structures similar to search trees, where the code is just so much simpler to understand recursively. All right, Ryan.
Yeah, I was just curious if we wanted to copy Walrus, but then be able to modify it without affecting whatever we copied it from. What's the appropriate way to do that?
Sure. So if we wanted to do it, real data structures or real classes should have something known as a copy constructor that looks something like, let me find the mystery of the Walrus code. So what you would typically do, if you wanted to make a copy, let's say, oh, I can't edit this, can I? Oh, here we go. Where's my Walrus stuff? Yeah, here we go. Typically what you would do is you would say something like W equals new Walrus W. And this would require you to have a constructor that takes an object of type Walrus and copies it. So that's the normal thing to do.
And how would it function inside the constructor?
So in the constructor would look like this. Public Walrus W. You would say this dot weight equals W dot weight, and this dot whatever the other thing property was, tusk size. Make sense?
Okay. So there's no fast way to do it?
Nope, not in Java.
Okay.
Well,
no
you know what? There is something called .clone, which is part of the object class. So object class clone. So there's supposed to be a clone method that does this, but for whatever reason, it like fell out of favor. Like, why is, sorry, is clone deprecated even? Nobody uses it. Why is clone not deprecated? Okay, let's see. Yeah, here's the debate. I'm gonna throw this in the chat for you. So, I saw the chat. We're on a tangent of a tangent. So this is some answers to, there was, like, you might think, doesn't that seem like such an obvious thing to do? There should be a built-in method that all Java classes should do. Yeah, they tried it. They put it in the language in the 90s, and it's broken. Yeah. Anyway, all right.
Appreciate it.
You got it. Cool. Steve.
Hi, Professor.
Hi.
So I have a question about like using JUnit for projects. So if you just want to like build your own, if you just want to write a regular class and you want to use JUnit in the class, how do you start? Like I know we used it in project in lab 2, and we installed it, but like if we just start running a project
from scratch
ourselves,
okay. So there's two ways. We did something a little experimental this time where we gave you guys these files called POM XML. So I will show you what these look like. This is what people tend to do in the real world, but it's a little annoying to set up. So if you wanted to do the lowest effort thing in our class to do it for your own code, what I would do is take one of our POM XML files, right? And then just copy and paste it. And as long as you have this stuff, and as long as you're, let's see, master Oh, you need master POM. Oh man. All right, never mind. I forgot there's a master POM. So if you create your own projects and you put it all in your like R repo, then you can do that. The other thing though, let me just show you real quick, is you could say project structure, and then you can go to libraries.
Yeah.
And you can click add a new Java library. And then as long as these two jar files are there, then it will work. So really you just need to make sure these two things are in the library for your project, which you get to through file project settings. Is that helpful? Yeah.
Yeah, so I just checked my library and I was trying to set up a new project and I didn't find anything in it.
Right. Okay, yeah. So what
So
you'll
I know there's a plus button. I could hit that and
yeah. So hit that plus button, go to
Yeah.
Java, and then wherever the library code is for our class. So it should be called like let's see.
Lab 2 setup.
Yeah, wherever that Java lib folder is.
Oh yeah.
Oh yeah, actually for you it's just
It's in library SP.
yeah. So you should add that folder. I don't think I have it downloaded right now, but if you do that.
So the whole Java lib folder?
Yeah, and so when you do that, let me try and find, I'll use the 19 library. So you'll click on Java lib like I have here. You'll click OK, and then it will say, you click OK, and then you should see Java lib appear. And once you do that, everything should work.
Oh, okay, now I see it. Thank you so much, Professor.
You got it, sure thing. And by the way, if there's one thing that I am so happy that we have in our class that other classes like ours are missing, it's JUnit. I think it's such a good practice. And I tried to pull people's teeth after I left Princeton. I was like, you guys, you have to put it in. They still haven't. But one day. Anyway, if any of you guys ever go teach at Princeton, I recommend that you get their data structures class to use JUnit. All right, Johnny.
Yeah, hi. So I have 3 questions, more so related to like using the IDE. But this one is, I think during the project, I accidentally clicked like the test code coverage button, and I wasn't able to unclick it. Not sure how to remove it. But what exactly does that do? And is that like helpful in any case with like unit tests?
Yeah. Oh yeah. Test coverage is a real world thing. What it does is it attempts to figure out how much of your code is exercised by your tests. I actually have never used the IntelliJ version of this. I've used it way back, but I haven't written software big enough to require it. But basically, it works like this. If I write a test that literally never calls resize, the code coverage tool will attempt to identify that and say, hey, you haven't written any code that makes sure this method gets called ever. Does that make sense?
Gotcha.
That's what it's supposed to do. Yeah. I don't know how it works. Voodoo magic, but yeah.
Appreciate it. And then the second one is, I know we've had to use Maven, and Maven's been referenced, I think, in a couple of the lab setups. But generally speaking, what I tried researching it. You know, it's like a software project management tool. What I guess, in your words, what does Maven do?
Sure. Maven is a way. So whenever you set up a project, there's a lot of things, right? Like what libraries you have, what Java language level you're using. So for example, if I turn this back to Java 8, my code will only work with all the Java 8 syntax features. So anything that's been introduced in Java since that time will no longer work. So Maven also allows you to, for example, specify the Java language version and so forth. Like any of this meta stuff that is part of your project setup, it can all go there. If we look at another one, I'll show you. There's in the POM we provide for you. This is something we added like in the fall. Basically, we started having people set this up manually. And so if we go look at the fall 14 or fall 20, sorry, well, Java 14, fall 20 directions, we are required people to like go through some settings where they had to turn this thing on. Where is it? Oh, no, I guess it's in the actual lecture. Wait, no, where is it? Okay, I swear. Yeah, nope, it's not it either. I'm sorry. I'm gonna find this thing. I want to show you the work we saved you. Where is it? Well, that's sad. I wanted that thing there. Anyway, it is a mystery. So one of the things that we like, one of the settings we have you guys using this time is showing details and exception messages, which when your code crashes because of a null pointer exception, it will give you more useful information than by default. And so there is a way to do that by going to File, Settings, you know, Java Virtual, oh, sorry, not that one. project structure, let's see, project, where's this thing? It doesn't really matter, but SDK, I don't even know where it is. But there's like a setting you can set up somewhere to enable this flag. But to avoid you doing all that setup stuff, we created these XML POM files that like automatically do all the config. Does it make sense?
Definitely. No, I appreciate that.
All right.
Thank
Sorry,
you
that was
for
a
clarifying.
way too long answer. All right. And what's your third question?
My third question was, I know we've been using like Java comments, and I was like clicking around trying to familiarize myself with J, and I ended up like generating a Java doc. I'm familiar with like the Oracle, the official documentation, and it looked actually similar to like an HTML doc. Why is that useful, for like non-official Oracle software?
Well, so if you write Java doc comments and you do things like param capacity or whatever, capacity of V-rate, what I can do is there is actually a somewhere, I don't know how to do it in IntelliJ, I know how to do it from the command line, where you can create the Java docs. See if I can find it. Code. Let's find out how to do it. Create Java docs. IntelliJ. Tools generate Java doc. All right, cool. So I go to tools, generate Java doc. I guess we'll do just, I can't do just one package. Okay, the whole project. Let's see what happens. Output directory. Okay. Well, let me create the file. Sorry. Java doc demo. All right, here we go. So if I do this and I say okay, all right, it's generating some Java docs of my giant thing. It's running into some trouble. All right, so now if I go there, hey, look, it's generated some documentation for my lecture code. I've never done this before with the lecture code, but I can go in and then click like, lecture 6 list 3, and it tells me about all my classes. And so you can see how good my Java docs are because the descriptions appear in some places. Like hit slist, then here's all the methods, like add first, adds X to the front of the list, returns the first item in the list, and so forth. All this was generated from my code. So that's why it's useful. Make sense?
Oh, that's awesome. Thank you.
Yeah, it's really cool. I love it. Yeah, maybe I should encourage you guys to do this when you finish project 3. All right, I got a hard stop at 2, and we finished all the questions, so perfect. Okay, so sorry everybody that I took us on the craziest long tangent within a tangent. But yeah, that's it for today. All right, I'll see you guys Wednesday. Bye, everybody.
Thank you, Professor.